Good morning, my YouTube viewers. It's Crystal here. I just want to give you a code review on Kaggle's Playground series competitions. This is Playground Season 3, Session 14, and it's to do with blueberry yields. And so what I'm going to have to do is I'm going to have to quickly give you the code review because I have to rush out to vote today because today is voting in the UK. And so this is, if you've been following Kaggle, this is the Playground series, and it's with prediction of wild blueberry yield. And so I did the machine learning program yesterday. I did it for a couple of hours. I tried about 4 or 5 times to get the best score possible, and my best score possible was 361. So it was on an MAE or RMS. I'm not sure. Maybe it was an MAE, mean absolute error. So the problem statement is predict on blueberry yields. That's your problem statement, and it's a regression model. So we're going to import the libraries. The libraries that we're going to be using in this program are NumPy as NP, which creates NumPy arrays and performs numerical computations. We're going to import Pandas as PD, and it's going to create series and data frames and also perform data processing. We're going to import OS, which goes into the operating system. We're going to import sklearn, which provides machine learning functionality. We're going to import TensorFlow Keras, which performs deep learning functionality. We're going to import matplotlib.pyplot as PLT, and that's going to provide your graphic visualization. And we're also going to import Seaborn, which also provides graphic visualization. So after we have imported our libraries, what we're going to do is we're going to go and use OS to go into the system and get the files. And the 3 files that we've got are train, test, and sample submission. And then what we're going to do is we're going to use Pandas to read the files. And so we're going to read the files that we obtained from OS, and we're going to convert those to a data frame, being train, test, and submission. So we're going to look at the train file. It's got 18 columns of data, 15,289 rows with 8 columns of data. And the last column is the yield. And yield is what we're going to predict upon in the test set. So we're going to describe the train file. So this gives you all of these statistics for all of the columns of data. So you've got the count, the mean, the standard deviation, the minimum, the 25%, 50%, 75%, and the maximum. We're going to check for null values. But one thing that I didn't mention in the previously was we didn't do an info. But if we had done an info, you would see that all of the columns of data are going to be either integer or float. And I can't do that right now because I'm just viewing the program and I'm not in the edit mode. We're going to check for null values, and you see that we haven't got any null values. So that's good. So we don't have anything to impute. And then we look at tests. We do the same with tests. We check for null values, no null values. And we look at submission. And this is the format that Kaggle wants to see when we submit our work. So the first thing we're going to do is we're going to drop the ID from the train and the test set. And the reason why we're going to do that is because you don't need it. The reason why it's not needed is because every row of data is indexed. Then we're going to analyze the yield, and you can see this is a histogram of the yield, so you can see that. We do a value counts on the yield, and you can see that the lowest value count is 7, so that means that we don't have to remove any rows where you have a value count of only 1. We're going to check for the number of unique values. So you check each column of data, and it tells you how many unique values that you have in each column of data. Now, what I could have done is I could have made a pie chart with some of these unique values, but all of the values were numeric. They were not categorical, and I decided that since the values were numeric and not categorical, I wouldn't have a pie chart. And then the next thing that we have is we've got our correlation. So we're going to create a heat map. But before we go create the heat map, I want to talk about these. If you wanted to, the thing is that all of the values in the data set are numeric. But if you wanted to, you could have done a scatter plot, or you could have done a box plot. But it would not have meant a whole lot because all the values are numeric. But we could have done a scatter plot or a box plot, but I didn't do it. But it could have been done. And I didn't do it because all the values are numeric, and I just didn't do it. I don't have an excuse. I just didn't do it. So now what we're going to do is we're going to create a heat map, and you can see in the heat map that we have quite a few columns of data that are highly correlated. And since these columns of data are highly correlated, you're going to have redundancy. So what we're going to do here is we're going to look at the correlation here, so you can see how highly correlated the data is. And now what we're going to do is we're going to drop rows that are highly correlated. And so core matrix equals train.core.abs. Upper equals core matrix dot where. NP true, NP1's core matrix. K equals 1, S hype equals bool. And it says to drop, we're going to drop any column that has a correlation higher than 0.95. And then I wanted to print the to drop. So these are the columns that we're going to drop. Min of upper range, average of upper range, max of upper range, min of lower range, average of lower range, average rainy days. And then, so those are what we dropped. And then I dropped them on the train and the test. Now, what I could do, if I wanted to, I could go back and not drop those and see if the score improves if I don't drop them. That's one thing I could do, like not drop the columns of data that are highly correlated and see if my error decreases. Now that's one thing that I could do, but I won't be able to do it this morning because I have to go vote. Now what we're going to do is we're going to define our x and our y variables. So y equals train.pop yield and x equals train. And then what we're going to do is we're going to split the data set up into training and validation sets. So you can see we've done that there. And now we get into TensorFlow. And so what we want to do is we want to import TensorFlow and Keras and all of the modules associated with TensorFlow and Keras that we're going to be using. Then we're going to standardize the data, and normalizer equals normalization, axis equals -1, normalizer dot adapt, NP array x train, print normalizer mean numpy. And so we normalize the data on x train, and then we check the first row of data on X-Train, and you can see what it is when it isn't normalized, and you can see what it is when it is normalized. So now what we're going to do is we're going to define our deep neural network, and we're going to call it blueberries because we're predicting on blueberry yields. The first layer of the DNN is going to be normalizer. The second layer is going to be a hidden layer. It's going to have an input of xtrain.shape1, activation equals ReLU, name equals hidden1, model, and then this next layer is going to be another hidden layer. We only have 40 neurons. I only put 40 neurons in for the hidden layer. And then we're going to have model add dense is going to be your output layer. And it's going to have only one output because it's a regression model. So this is a summary of the model that you can see. Now what we do is we compile the model. We use RMS prop as the optimizer, loss is MSE, metrics is MAE. We set up for early stopping and model checkpoint. So what we do is we set it to save the best model, and then we train the model. History equals model.fit, xtrain, ytrain, batch equals 32, epochs equals 500, validation data equals xval, yval, callbacks equals early stopping and NC. And then so we train the model. And then after we train the model, you can see it did an early stopping at epoch 236. So now we're going to evaluate the model, and it has the MAE of 350, 98.9871. Now what I've done is I've created a chart to plot the loss in the MAE. So you can see that the loss and the MAE are pretty much the same. Now we predict on the validation set. When we predict on the validation set, we have MAE of 350. We plot the actual values against the predicted values. So you can see that's what they look like. Now what we do is we create a data frame of the actual values against the predicted values. Now what we're going to do is we're going to predict on test, and then prediction equals the absolute value of prediction. So that's just in case you get any negative numbers. Because you're not going to get a negative yield. You'll get a zero yield, but you won't get a negative yield. So we check our sample submission, we prepare our submission yield equals prediction, submission.toCSV equals submission.CSV, index equals false, submission equals pd.readCSV submission, and this is your submission. And this is what I submitted to Kaggle, and I got a 361. Now what I might do, which I can't do it this morning because I have to go vote, is I might not delete those or not drop those columns and see if it improves my score. And everything else that I didn't do, like the scatter plot and the box plot, that was definitely just for analysis, and it wouldn't affect the MAE. It would affect the analysis, but it wouldn't affect the MAE. But I didn't do it because the numbers, there was not any categorical values, and so the numbers didn't really mean a lot. But I could go back and do a scatter plot and a box plot as well, just to aid in the exploratory data analysis. But it's after 9 o'clock. It's time for me to go vote. So I'm going to have to conclude this code review. I hope you got a lot out of it. I'm going to be making a blog post on it as well. So thank you for watching my code review, and I look forward to making more code reviews for you in the future.